Hey guys, how we doing? We decided to move inside. We were getting eaten by bugs. So we're on section 5. Almost done with the chapter.
Almost done.
Got one more after this. Describe angle pair relationships. And so we're doing just that. We're pairing up angles in different ways. And there's a couple of terms here that you got to be clear that you keep them separate from each other. And critical because we use them for the rest of the year. And so let's see what we got here. Complementary angles, that's one of the terms. And so complementary angles are two angles that add up to 90 degrees, two angles that create a right angle. And so you got to keep that word complementary with 90. Absolutely critical to keep those together. So two angles that are complementary means that they add up to 90 degrees. And so when we're talking about one angle compared to the other, then we talk about the angle's complement. And so if we had an angle and we wanted to find its complement, it would be the missing ingredient or the missing piece to add up to 90 degrees. Okay, so we have an angle and its complement. We have an example there, I'm sure. And so here's an example of two complementary angles. Angle 1 and angle 2 add up to 90 degrees, and so they're complementary to each other. And we would say that angle 1 is the complement of angle 2, and angle 2 is the complement of angle 1. And what numbers that come in here? Oh, this is an algebraic example. And so if we know that one of the angles measures 3x, the other one measures 6x, well, we know they add up to 90, kind of like our bisected angles in a way.
Yep.
And so we would, instead of setting those equal to each other, they're not bisected, we just know they add up to 90 degrees. So instead of setting them equal to each other, we'd set up an equation that adds those two angles together, equaling 90 degrees. And so we'd go 3x plus 6x equals 90, and solve that equation. So it would be 9x equals 90, divide by 9, x equals 10, plug that 10 back in again, and we're going to get 30 for one of them and 60 for the other. And so that would be solving that equation. I'm not sure that they don't go through the steps there. So
Now, one thing to keep in mind here, guys, is this picture, this diagram, has what we call adjacent angles because they share a piece BD in there. But you can be complementary and not be adjacent still.
That's true.
Meaning that if you had a 30-degree angle on one side of your house and a 60-degree angle completely on the other side of your house, if you were to add those two together, they would still be complementary, even though they're not touching one another.
Right.
Any 30-degree angle added with any 60-degree angle will make a set of complementary angles. So they don't have to be what's called adjacent, which is like the diagram here. They can be separated.
Yeah.
Okay?
Good point.
Yeah.
Okay. I don't know why I have a red box.
Yeah, it's weird. So supplementary angles, guys. So this is complementary's counterpart, and it's two angles that add up to 180 degrees. And so basically that's the big difference, or the other one Mr. Critchwell was kind of leaning towards here was you've got to remember that complementary adds up to 90, and you got to remember that supplementary adds up to 180. Right. I mean, it's pretty simple. We're not pulling any punches with you guys on this stuff. So remember, a straight angle has 180 degrees. And it also starts with S. So if you need another way to remember it, supplementary is like straight angle, 180, 180. And they just have to add up to 180 degrees. And the same idea applies, like in this diagram here, you have a pair of adjacent supplementary angles. And just like on complementary angles, they don't have to be adjacent. They don't have to be touching one another, or be what's called a linear pair. They don't have to be that way. You could have one angle over here, one angle over here, and as long as they add up to 180 degrees, they would be considered supplementary. So let's see what they pop in here for us. So if angle BDC is 20 degrees, well then what would angle BDA be? Well, that's easy, 180 minus 20, and that gives me 160 degrees.
Yep. So
pretty straightforward here, guys.
Yeah, just got to keep them straight from each other.
Yep.
Yeah, complementary 90, supplementary 180.
Yep.
Okay. And so some of the terms that Mr. Badella was just using, one of them is a linear pair. A linear pair, again, you can break down the word. Linear means line. And so it's a pair of angles that make up a line. And so it's basically like our last diagram, or this diagram here, two angles that are right next to each other. And that's what the word adjacent means. So two adjacent angles, adjacent means right next to. And so we have two adjacent angles here, angle 1 and angle 2 are adjacent, but they also make up a straight line. So because of that, they're called a linear pair. Because they make up a straight line, and a line is 180 degrees, they're supplementary. Okay? So adjacent doesn't necessarily have anything to do with supplementary. Just two adjacent angles, they could be complementary, they could be add up to any number. They're just next to each other. Linear pair means they're supplementary. Linear pair means that they add up to 180. Supplementary means they add up to 180. So a linear pair is always supplementary to each other. Okay?
And just to kind of go over with adjacent again, because this is kind of that weird, we use adjacent later on in the year and it means something completely different. But when we talk about angles, an adjacent angle, or what makes these two angles adjacent is that ray BD or sorry, ray DB, and that's the side that they both share. Now,
Sure.
you don't want to say that they share DC and they share DA. That's not true. So just be careful there when you think adjacent. It's the side that both of them use, the whole side that both of them use.
Yeah. Adjacent angles, yeah, they share a ray, share a side, and they're right next to each other. However you want to think about that.
Yep.
Okay.
All right, now this is one of the most important ideas, I think, out of chapter 1.
Yeah.
This is a very important word. We use it quite a bit for the rest of the year, and it's a really easy concept. Two angles are vertical angles if their sides form two pairs of opposite rays. I always think of vertical angles as opposite angles, and it'll make a lot of sense here when you look at the diagram coming up here in a moment. But like I said, I think of them as opposite angles. There it is right there. Let's look at a diagram here, or more and more stuff's coming out. These are created whenever two lines intersect. So if you think of an intersection of two streets, you get, in essence, you get vertical angles created there. You have the north side of the street, you have the south side of the street, or the intersection. You have the west side of the intersection, you have the east side of the intersection, and those are, in essence, vertical angles. And so if you look at this drawing right here, you see the two lines intersecting, and it creates four angles: angle 1, 2, 3, 4, like they're labeled. And if you go back to that red word up there, opposite, well, angle 1 is on the left. Well, his vertical partner is angle 3, who's on the right, and angle 2 is on the top. And so just opposite of him is angle 4. So I can, based on this idea of vertical angles, I can say that angle 1 is congruent to angle 3, or sorry, angle 2 is congruent to angle 4 there, based on those blue shading there, and angle 1 is congruent to angle 3. So if I know that angle 3 is 47, I can just go off what the definition said, that vertical angles are congruent, and say that angle 1 must also be 47. Now, to figure out what angle 2 and 4 are, oops, let me go back here. To figure out what angle 2 and 4 are is we know from, all the way around, if I started at the bottom of angle 1 there and I just went all the way around that first line there, that arc would be 180 degrees, or those two angles would be supplementary, or you could call them a linear pair. All that vocabulary we're using today, we could just go 180 minus 47, and that gives me that 133. And if it's 133 on top, then it's got to be 133 on the bottom, because opposite angles are congruent.
Yeah. So there's lots of relationships going on here. Lots of relationships in terms of angles, vertical angles being equal, which we haven't necessarily even gotten to that. We're just defining what vertical angles here are. But then adjacent angles here being supplementary to each other. And so there's lots of different ways of calculating things.
Right,
now.
right.
Yep. And so we want you to do just that with some algebra mixed in.
But you got to be real careful when you look at this problem.
Yeah.
Because there's an x and a y in there. And you got to think about algebra, guys, and just be careful when you go through this problem.
Yeah.
Okay? Because you can't put an equation with x and y together and try to solve it.
No. This is one we're asking them to do, correct?
Yep.
Yeah.
No, actually, we do this one. There's
This is our example.
Just because of that y in there, I didn't think it was fair to try to pull this one on them.
No, yeah, and so we don't want to go
No.
with the fact that those are opposite. In fact, we really don't have that rule yet.
No, that's
So we
right.
can't say that those are equal. We don't have that rule yet, guys, so don't jump ahead too much here. But we do know that the two angles that have x's in them are supplementary to each other, because they are adjacent angles that form a line BD. And so, because they're a linear pair, they add up to 180 degrees. And so we would add those two angles together, 16x minus 4 and 14x plus 4, and set that equal to 180 and solve that. And so I don't know, is that on here? Probably not with
No.
the things on there. So 14x plus 16x is 30x. The 4's actually cancel each other.
Yep.
And so we have 30x equals 180. Divide both sides by 30, and we get x is equal to 4. And so once we have, where did I get 4 at? 6. 30 goes 186 times. And so once we have that, then we can figure out the angles, and our little angle symbols are missing here. But measure of angle, you know what? I just realized we didn't talk about what that little m means.
Oh, that's true.
I think we had that on an earlier slide, and we didn't talk about that.
Right.
But that little m in front of the angle, remember back when we were talking about segment notation, when there was no segment or no line or no ray or anything above it, just nothing there, it meant the length of that segment. Well, in order for us to do that with an angle, we put a little M in front of the angle. And I don't know where our little angle symbol is in the PowerPoint here, but you read that as measure of angle AED. And so that's what that little M means out in front. And so if we want AED, that angle on the left, that's 16x minus 4, we would take our 6 and plug it in there. 16 times 6 is 96, minus 4 is 92. And so that angle has to equal 92 degrees. Okay? You could get DEC a couple different ways.
Yep.
If you know that's 92, DEC and the one we just found, 92, are a linear pair. So they have to add up to 180. So we could subtract the 92 from 180 to get the measure of angle DEC, and that would be 88. Right? Okay. And then how would we figure out y then if we can't put an equation with x in there?
You just, now that we know that DEC is 88, we're just going to go 4y minus 8 equals 88. Do some math. So add 8 over, you get 96. Divide 96 by 4, and we get 24.
There you go.
Hey, one thing on that little M that Mr. Scritchell was talking about, if you ever forget, M is like for math, so you got to do some math. They want a number. When you see that little
Back
M.
to what you were talking about earlier.
Yeah.
We're not talking about a picture of an angle.
Yeah, we're talking about the
math of an
mathematical number that
number that
represents
goes-
that angle.
Okay.
And so if you see that M, just think the math number.
Okay, good.
You know,
Yeah.
just another way to maybe think about it.
Okay. Yeah.
And then for homework, guys, we want you to find all the missing angles. So you're gonna have to do a little bit of algebra on this one, but same idea as on the previous night's video, where you had to go through and try to find those missing angles. Same thing here. Once again, you see the 90 degree in there. Use that to help you, and just work
Yeah,
your
that's
way
a
around.
big clue there. You got to make sure you pick up that right angle there.
Just draw the picture and then fill in the angles that are missing with numbers. That's probably the easiest way to do it.
Yeah.
Okay.
Okay, guys, do those as an example. Bring those to class first thing tomorrow, and we'll go through those and go from there. See you guys in class.